we are going to discuss about the topic accuracy, precision of instruments and error in measurement. Okay, at first we will learn what accuracy is and what precision is. Okay, first we should know accuracy. Let us consider this is any object. Consider this is length of an object. Okay, and you are given to scales. You are given to scales by which we can measure, or you can measure this length of the object. Okay, first of all, you are given a scale having centimeter cut marks. Okay, cut marks are given in centimeter. This is what in centimeter range. Okay, and other scale is given you in the cut mark with millimeter. Okay, it is given like this, and this is in what? Millimeter. Okay. The measured value but in the laboratory or in the factory where this object is made is about let us consider 1.7 30.3067 meter. Okay, 3067 meter. Let us consider this is the real value of this object, length of this object. Now if we use this centimeter scale, okay, and you got the value is, let us consider 325 meter. Okay, if we see this 0.325 meter and this value, we observe that the difference between this value and this value is higher than this and this. That is what? That is the value measured by this centimeter scale is more accurate to the measured value by millimeter scale, because this value is close to this value than this value, right? So this value is close to this. That is what? That is the measured value by centimeter scale is more accurate to this value. That is what? Accuracy. More accurate. Okay, that is accuracy. Now if you observe that what precision is, okay, we got the value here by 3 digits are there. That is what? We measure precisely in millimeter scale. That is, there is less probability in error by measuring. In the book it is given that the accuracy of a measurement is a measure of how close the measured value is to the true value of the quantity. What is true value? This is true value, and this is what? These are the measured value. So which measured value is close to this true value? That is this value, close to this. Therefore this is what? More accurate value. Okay, and this is what? This is true value. Okay, and what precision is? Precision is, in the book, precision tells us to what resolution or limit the quantity is measured. Okay, this is more precise. This is more precise. This is more precise because it gives the more resolving ability. Error. What error is? If we measure something, there is some approximate. For example, if you go to buy 1 kg of potato, okay, then in the balance you see that 1.025 kg. Okay, you buy this amount of potato. this quantity of potato you bought. Okay, that is, you want how much? 1 kg, but you are given 1.025. okay, this is what? This is what? This is, we will call approximate value. Approximate value. Okay, this approximate value is due to error, because this is what? Approximate value. In error, in measurement, there is always approximate due to, in measurement there is always approximate due to error. Okay, we will learn in measurement there is always approximate due to error. Clear? So we should learn errors. What errors? Errors are broadly divided into two parts. That is, number one, systematic error, and number two, random error. Okay, first is systematic error, second one is random error. Okay, in systematic error, first is instrumental error. Okay, what instrumental error is? If you are going to measure temperature of body by a thermometer, okay, if thermometer is designed in the laboratory, then laboratory that 100 degrees Celsius is what? Boiling point of water. Okay, but if we boil water and place the thermometer in the boiled water, then we saw that 105 degrees Celsius. What does that mean? That means there is error exists. But we know that 100 degrees Celsius is the boiling point. From where this difference comes? 5 degrees Celsius difference is there. Why this is happening? This is happening due to instrumental error. When the thermometer is made, that exactly 100 degrees Celsius is not boiling point by this thermometer. Okay, so this type of error is called instrumental error. Clear? Okay, next one is number 3 is imperfection in experimental technique. Okay, in the NCERT book it is given that in a thermometer, when we measure temperature of body by thermometer, we place the thermometer like this in the armpit, then we will get the value, but this value is always less than the temperature of our body, always less. That is the value is less than the true value. That is occur in imperfection of experimental technique. Okay, in experimental technique this kind of error arises. Okay, next one is personal error. Okay, personal error is personal, that is individual wise the error is different. Okay, for example For example, if we measure, if we are measuring current through a circuit, you are measuring what? Current through a circuit. Clear? Then the emitter reading will be like this. This is the emitter reading. Okay, there are cut marks. There is a scale. Okay, the needle is, let us consider needle is like this. Okay, in this case, if we see the arrow from the top of the arrow, if we see the arrow from the top of the arrow, then we will get the value of this. If we see from this side, then the needle is observed like this, and if we see from this side, then this is look like this is the arrow will be look like here. Okay, that is true value is this, but from the other side the observed value is different. Okay, this is called personal error. Clear? Okay, after that this is also called parallax. We have already learned in the parallax method. Okay, these are the systematic errors which can be minimized. Actually, systematic errors are always in one direction. Okay, this is in one direction. Now we are moving to random error. We are moving to what? Number B, random error. Random error. Okay, what random error is? Random errors which the errors increase abruptly in any condition. Let us consider you are doing a chemical reaction. Okay, you are observing some reaction at, let us consider at room temperature 27 degrees Celsius. Okay, you are measuring or observing the or doing the experiment in 27 degree Celsius temperature. Instantly the weather change and temperature decreases to 20 degrees Celsius. Let us consider there is a heavy rain and the weather temperature decreases to 20 degrees Celsius. Clear? Then what happened? The temperature change occurs. Okay, but in the first half hour, let us consider it is in 27 degrees Celsius. The next half hour is at 20 degrees Celsius. Obviously, the result will different. Okay, this type of error is called what? Random error. Or let us consider the circuit. You are measuring the current through the circuit. Okay, and this you will observe the value in emitter. When let us consider some voltage increases abruptly. Okay, voltage increases, then what will happen? The current will flow. Clear? Then the reading will be different from the prior. Okay, this type of error is called random error. Clear? After that, least count error. Least count means moving to the least count error. Least count error. By least count, least means small, count means calculation. If we see the 6-inch scale used or the scale inside your compass, okay, if you observe, then you will see two type of scale. Okay, in this scale there is inch, and in there are 6 inch. Okay, 6 inch. 6 inch scale, and there is also in 15 centimeter. Okay, like this. This is 1 centimeter, 2 centimeter, like this. Okay, this is 1 centimeter. Okay, there are small divisions which are called millimeter. Okay, by this scale we can measure minimum value is how much? 1 millimeter. We can accurately or correctly measure 1 millimeter. Okay, if we have to measure less than 1, that is 0.5 millimeter, then there will be no accuracy. Okay, accuracy will be minimum. Okay, so least count means the minimum measurement can be done by that instrument, a measuring instrument. So this is the measuring instrument, and by this instrument we can measure minimum 1 millimeter. Therefore 1 millimeter is the least count of this scale. Clear? Okay, like that there are some scales called vernier scale, vernier calipers. Okay, vernier calipers. By these vernier calipers, we can measure minimum 0.1 millimeter. Okay, this is the least count of vernier calipers. Similarly, there is another measuring instrument called screw gauge. Screw gauge. By this instrument, we can measure 0.01 millimeter. We can measure minimum 0.01 millimeter. This is called least count of the screw gauge. Clear? So so there is also some error in least count, which is associated with resolution of the instrument. Okay, by lower the least count, higher the accuracy. Okay, so least count error may be higher in low least count instrument. Absolute error. Okay, we will see what absolute error is. Let's consider this is an object. AB is an object. Its length is, let us consider its length is how much? 30 centimeter. Okay. From your class, let us consider from rule number 1. We will measure this object by scale, and he get the value A1 is equal to 30.5 centimeter. Okay, he measured how much? 30.5 centimeter. Originally, what is the value of this scale? That is 30 centimeter. This is called true value. This is called true value. Okay, which is the exact value, that is called true value. Okay, A1 measured the value as 30.5 centimeter. Next, another boy measures the scale by 30.1 centimeter. Next, another boy come and measure the object and got the value as 29.5 centimeter. Okay, another boy come and measure the value and got 31.5 centimeter. Here, another boy come and get the value as 29 centimeter. These are the values or in the different boys measurement. Okay. Here, exact value is what? 30 centimeter, and they get the values as values like this, and there are always some error. Okay. Now, absolute error we are going to measure. Okay. Next one. This is what? True value. If this true value is not given to you, okay, if true value is not given, then how can you measure true value? Then you have to find average of the measurements is true value. Okay, average of the measurements is true value. That is, true value can be found as average average. Okay, we can find A average as A1 plus A2 plus A3 plus A4 plus A5 divided by number of measurements, that is 5. So we can find the average is 30.5, 31.1, 29.5, 31.5 plus 29 divided by 5. Okay, what will be its value? 30.5, 0.6, 0.6, 0.6, 0.6, 1.5, 1.5. Okay, and the other value is 29.5 minus 0.5 minus 1. So 0.6, 30.6 divided by 1. Okay, 30.6 divided by 1. So its value will be how much? How much its value? 306, 5, 30, 26, 6. So 1, 155, 102. So 6.12. 6.12 is the value. Okay? Okay. Oh. Sorry. Okay, this value is 30.6 what centimeter is the average value. Clear? Now what is area average? Area average is 30.6 centimeter. Clear? Now we are going to measure absolute error. Absolute error is nothing else. It is only the difference between the true value and the measured value. Okay, absolute error is the difference between the true value and the measured value for the measurement. Okay, for measurement of 1, for measurement of 1, for measurement of A1, absolute error is delta A. Okay, absolute error is delta A is measured value minus true value. Okay, what is the measured value? 30.5 minus 0.6. 30.12. So A average is equal to 30.12 centimeter. Please calculate it out. Okay, its value is 30 point how much? 12. So next value is how much? 30.5 minus 30.12. 0.38. Okay, what is this absolute error? Delta A is equal to measured value by human. Okay, for first value A1, that is delta A1 is equal to 30.5, 30.12 centimeter. 30.12 centimeter is what? A average, which is true value. Okay, please correct. So this is what 1 centimeter is error. What type of error? This is absolute error in measurement of A1. Okay, for the second one, for second measurement, for second first measurement, is delta A1, this is equal to 4. For second measurement, error is delta A2, which is equal to how much? 30.1 minus 30.12, that is 0.02 centimeter. Okay. Similarly, for third measurement error is delta A3 is equal to how much? 29.5 minus 30.12 centimeter. So its value is minus 6.62 centimeter. Okay, 0.62 centimeter. Okay, the fourth measurement is for measurement of fourth measurement. For fourth measurement, error is delta A2. Okay, delta A2 into delta A4, which is equal to how much? 31.5 minus 30.12. Its value is 5. Okay, 8, 3, 8, 1.38. Okay. For fifth measurement error is delta A5 is equal to 29 minus 30.12 centimeter. Its value is minus 1.12 centimeter. Right? Okay. So these are the absolute errors in each measurement. Okay? So each measurement we got the values. First of all, we got this is delta A1, delta A2, delta A3, delta A4, delta A5 are absolute error respectively in the measurement of 1, 2, 3, 4 and 5. Okay? Clear? Clear? These are the absolute measurement. And absolute measurements are always considered in positive. Clear? Therefore, in the all cases we can take as modulus. This value is how much? 0.62 centimeter. Okay? And this is the negative value. This is the negative value, which is equal to 1.12 centimeter. Clear? We can take modulus of the value of negative value. Then all are positive. All are positive is in absolute error. Next one is relative error. Clear? Next one is relative error. Okay. Okay. Next one is relative error. Relative error. Relative error is the ratio of delta A average error. Okay? Okay. Relative error is the ratio of average of absolute error average of absolute error to the average of average of mean absolute error, sorry, ratio of average of absolute error to the average of mean values. That is delta A average or mean divided by A average. Clear? Okay, delta A average by A average. Okay, now what is delta A average in this case? Delta A average is what? So you can see the values 0.38 plus 0.02 plus 0.62 plus how much 1.38 plus 1.12. Okay, delta A average equal to divided by how many times we have considered? 5 times. Okay, so its value will be the delta A average. What will be its value? 0.38 plus 0.02 plus 0.62 plus 0.1 1.38 plus 1.12. 0.38 plus 0.02 plus 0.02 plus 0.64 plus 1.38 plus 1.12 3.52 divided by 5. Its value is 0.74 0.704. Okay, this is what in centimeter. Clear? This is what delta A average. So average of these absolute errors. Clear? This is the average value, and we know that A average is how much? 30.12. So we can write here. Relative error. The delta we can write. In your NCERT book, it is denoted by delta A. Okay? No. Delta is percentage error. No problem. Direct relative error is written in your NCERT book. So relative error is equal to how much? Delta A average, which value is 0.704, and A average is 30.12 centimeter. So relative error is dimensionless. We can find out this cutoff. So this value is 30.12. So 0.0233 is the relative errors in this case. Okay, clear? This is what relative error. Clear? Next we can find percentage error. Okay, percentage error is nothing else, only the relative error into 100%. So we can write relative error as delta S, the ratio of we can write A average divided by A average into 100%. This is what percentage. That is what relative error into 100%. So we can write how much the relative error 0.0233 into 100%. Okay, it will express as how much 2.33 percentage. This is what percentage error in this case. Clear? So this is the introductory idea of accuracy, precision of instrument and errors in measurement. Clear? Next we will study addition in error and not error. Errors in addition, errors in multiplication, error in subtraction and error in division we will learn in the next class. Okay? Thank you.